Okay, Geometry, Chapter 5, Section 3, Medians and Altitudes of Triangles. Please pause the video, and when you have answered these questions, come back and check your work. Okay, number 1, what is the name of the point where the angle bisectors of a triangle intersect? And that is the incenter. Very good. Midpoints of the segment with these endpoints. And recall we need to find the average of the x and the y, right? So we have, in this case, 1, 3. And for number 3, we have a midpoint at -5, -3. Number 4, write an equation of a line containing the points 3, 1 and 2, 10 in point slope form. Remember, point slope form is y minus y1 equals m, your slope, times x minus x1. And so you had to use these points to find what first? That's right, slope. And then you could use either point in point slope form. So they chose to use the first point. If you chose the second point, you could write the equation y minus 10 equals -9 times x minus 2, right? That would work as well. Okay, the objectives today are to apply properties of medians of a triangle and apply properties of altitudes of a triangle. So let's see. A segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. This segment that begins at a vertex and ends at a midpoint of the opposite side is a median of a triangle. That's what that is, the median. So every triangle has 3 medians, right? And the medians are concurrent. Recall that from our last lesson. Look, we could draw a segment from vertex B to the midpoint of AC, right? And we could draw one from a median from vertex A to the midpoint of CB, and they would be concurrent. And here we have that point, don't we? The point of concurrency, then, of the medians of a triangle is the what? Is the centroid of the triangle. So the centroid is always inside the triangle. And the centroid is also called the center of gravity because it is the point where a triangular region will balance. So this is you can imagine the name, right? The centroid theorem. And it says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So AP is 2/3 of the entire AY, which means PY would be 1/3 of AY, right? BP is 2/3 of the entire BZ, and C to the centroid P is 2/3 of the entire median CX. In this triangle LMN, RL equals 21 and SQ equals 4. Find LS. Interesting, find LS. So we know that LS is 2/3 of the entire RL, right? And that is the centroid theorem. And do we know RL? Aha. We are given that, aren't we? So we can use substitution to complete this expression on the right? And so now we can simply find 2/3 of 21, which is 14. So LS is 14, and that's just simplifying the previous expression, multiplication, right? Very good. So this information about SQ, was that necessary to answer the question? No. In triangle LMN, where RL equals 21 and SQ equals 4, can we find NQ? We need the entire segment NQ. So recall that NS is 2/3 of NQ, which means SQ would be what? That's right, 1/3 of the entire NQ. Okay, so we know that NS is 2/3 of NQ, centroid theorem, and so we can say that NS plus that little SQ equals the entire length of NQ, and that's the segment addition postulate, right? We're adding segments that make up the larger segment, and so we are now going to probably substitute what we know up here. We know that NS is 2/3 of NQ, so we can plug that in, plus SQ equals NQ, and that's simply substitution. And so what can we say now? We can, I guess we could plug in something else, couldn't we? We can say that SQ equals 1/3 of NQ. And I guess what has happened here is what? Subtracting 2/3 from both sides, right? And so subtraction property of equality. And now we can say that 4 equals 1/3 of NQ, right? And that's by substitution. And so we can say that 12 must be NQ, multiply both sides by 3, right? And there we go. Okay, in triangle JKL, ZW is 7. LX is 8.1. Find KW. And come back and check your work. And so you're probably doing this rather quickly, knowing that ZW is 7 and it is 1/3 of the entire length. Then what is 7 times 3? That's right, KW is 21. We can walk through it step by step. We know that ZW is 1/3 of KW. That was a correction from the key. This is based on the centroid theorem. And that's because we're looking at the smaller 1/3 piece of this median, right? And now we know that 7 equals 1/3 of KW, and that's by substitution. And so we simply multiply both sides by 3. Okay? So we're going to learn another term here. Something is a perpendicular segment from a vertex to the line containing the opposite side. This is an altitude of a triangle. It is a perpendicular segment from any vertex to the line containing the opposite side. Okay. Every triangle has 3 altitudes. We can draw a perpendicular segment from any of the 3 vertices, right? And an altitude can be inside, outside, or on the triangle. So in this triangle QRS, altitude QY is inside the triangle, but RX and SZ are not. Notice that the lines containing the altitudes are concurrent way out here at P. This point of concurrency is the orthocenter of the triangle. So where all of the lines that contain the altitudes converge, out there at a single point we have the orthocenter of the triangle. So here's a helpful hint. The height of a triangle is the length of an altitude. Remember, it's always perpendicular. Heights are perpendicular. So in your notes, I have left this series of slides open with the answer included, but let's take a moment to really understand and slowly walk through these so that it will make sense for you when you study it. So we're asked to find the orthocenter of triangle XYZ with vertices shown here at these given points. So the first step, of course, if you didn't have the image in a coordinate plane would be to put it on one, right? So we graph the triangle, as you can see here in step 1. And so if we're going to find the orthocenter, we need to find the altitudes, right? And at least 2 altitudes where they converge then will give us the orthocenter, right? The 3rd altitude would converge at that same point. So we simply need to find 2. So the easiest altitude to construct would be where? Where do you see? Well, we can easily go from point, it looks like point Z, which is at 7, 1, and create a perpendicular from that vertex through this base over here, YZ, right? So that's the first altitude drawn. So XY is vertical. So it's the altitude here from Z is going to be horizontal. And so it must pass, as it says here, it must pass through this 0.71. So the equation would be y equals 1. And there we have the first altitude. Now, the other altitudes are going to be a little trickier to find because we've got to make sure that they're perpendicular. And if they are perpendicular, then they would have a slope that is going to be compared to the slope of the base that we're running into, right? So if we're moving from vertex Y and finding an altitude that would move to this segment here, ZX, we need to know what this slope is, right? So that we can find the negative reciprocal slope and use it from point Y, which is exactly what is done here. So the slope of the line that is perpendicular to XZ, let's look again, XZ is -4/3 because the slope of XZ is 3/4. So -4/3 is the negative reciprocal, right? The perpendicular slope. This has to pass through 0.36, this point here. So point slope form could be used to write the equation, right? We'll use that point and the perpendicular slope to write the equation, and there it is. And so this can be used now to graph that line, and we can locate here the coordinates of the orthocenter. So in this case, we are solving a system. What point can be found on both of these lines, right? So we're going to solve the system and see what point that is. Okay, we're using substitution to solve. If y equals 1 and y equals -4/3 x plus 10, we can simply substitute 1 for y, right? 1 equals -4/3 x plus 10. Now we solve for the one unknown, x. Subtract 10 from both sides, multiply by the reciprocal, and we find the x value of 6.75. So the coordinates of the orthocenter are at 6.751. Okay, if we were to find the altitude from x to this space over here, x or YZ, we would find that it would converge also at 6.751. A lot of work, but it's worth it. Okay, pause the video, try these, and then come back and check your work. So use the figure here to answer the question. Length AG would therefore be 8. GC would be 14, right? And GF, you should have 13.5. And for these two items, you were to use the given triangle, right? And the centroid is at 0, 2, and the orthocenter, which is a little more labor intensive to find, right, should be at -2, -2/3. Okay, really persevere through that orthocenter topic and do a good job and have fun with this assignment.